This video will be going over the process of building your hovercraft, and then we'll have a brief discussion on how to go about calibrating it and interpreting your data. The list of materials and access to all other guides and helpful diagrams can be found on our website under the Kit Instructions page, which is linked in the description below. The first step here is to cut the skirt for our hovercraft. Now for the skirt material, we're using just a trash bag here, and you can use any sort of trash bag you'd like, but you'd prefer to use a heavy duty one just so your skirt lasts for a longer period of time with testing. Now again, you can use any type of trash bag, but when you're using this trash bag, you want to open it up so you can lay it flat on a table just like a thin sheet of plastic. Then we can lay our hovercraft base on top of it, and what you can see me doing here is I'm taking a ruler and I'm marking 1/2 inch away from each edge of the hovercraft base. Then what we can do is we can take a razor blade and cut out essentially those markings to make a rectangle for the skirt. Now you can definitely make this skirt larger by measuring more than 1/2 inch away, but I wouldn't recommend doing more than 1 inch away. There really just is no benefit outside of that. And now what we're going to do is we are going to attach the skirt to the base. And to do so, you just need some Scotch tape. And what we're going to do here is we're going to essentially fold up each edge of the skirt so that there's between 1/8 of an inch to roughly 1/4 of an inch of that skirt material covering the edge of the hovercraft base. Then we can take some tape and tape that hovercraft skirt down. And we can repeat this process throughout the rest of the edges. Now when you get to the corners, you also, again, it's a little bit tricky, but you just want to fold that corner over and tape it down just to make sure there's no air leaking out from that spot. The next step here is to attach our blower or lift fan to the center of our hovercraft base. This fan essentially inflates our hovercraft skirt and allows it to quote-unquote levitate. Now for this step you need a 1/2 inch long number 6-32 bolt and a number 6-32 hex nut. We can make this attachment of the fan a little bit more secure by just adding a little bit of hot glue in the spot where the fan touches the hovercraft base and where it inserts into the slot. Now you'd prefer to use hot glue over a more permanent type of adhesive in case you end up deciding you'd like to use a different fan in the future. Or if you are using a different fan than what we are recommending in our materials list, I would highly recommend using a hot glue instead of a more permanent adhesive in case you end up realizing that a stronger fan would be required. Now per the rules, all fans have to have some sort of or some form of a guard. And while there aren't necessarily a whole lot of guards for these blower type fans, surprisingly the 92mm square fan guards fit these fans very well. So we're just simply going to screw in these fan guards with these screws included with the guard. Now we can assemble our thrust fan and attach it to the base. For this step, you're going to need 2 fan guards for a 120mm PC fan, and you'll need 4 number 6-32 bolts that are 2 inches long and 4 number 6-32 hex nuts. So what we can do here is we can first attach the fan guards to the top 2 corners of the fan, and then we can go ahead and attach the fan to the 2 holes on the hovercraft base piece. Now we can go ahead and attach our rheostat to our rheostat holder using some epoxy. Now, this rheostat holder is designed only for 100-watt rheostats. That means if you use a rheostat with a lower wattage rating, it will not have the diameter to fit in the holder. It would be much smaller than the 100-watt rheostat. So this step is relatively self-explanatory. We're just going to mix some epoxy, run it along the edge of the rheostat and the rheostat holder, and then insert that rheostat into the holder and let it sit for at least an hour. And after letting all of that dry, we can now attach our rheostat to the top of our lift fan using the 2 holes on the lift fan and 2 number 6-32 bolts with a length of 1/2 of an inch and 2 number 6-32 hex nuts. So now what we are going to do is we are going to attach some wires to 2 of the rheostat terminals. You want to attach one to one of the golden terminals and one to one of the center terminals. Now I am intentionally using 2 red wires because this rheostat will only contain one polarity. Right? You don't want to use a red wire and a black wire, though it doesn't particularly matter. Just to make sure that you understand what's going on, we are just using 2 red wires. So what we're going to do is we're just going to twist these wires onto these 2 terminals. Then I'm going to take a soldering iron and make that connection a little bit better. Then we can come back with some heat shrink and make this connection even more secure. And again, now we can just place some heat shrink over the wire and the terminal to make this connection a little bit more stronger. The next step here is to attach the batteries to the hovercraft base. Now to do this, we're just going to be attaching 2 ends of Velcro, 2 opposite ends of Velcro, to either the battery and the other end to the hovercraft base. Now, something you may notice is that the batteries we are using are 8.4 volts, and the maximum battery voltage for this year is 12 volts. However, we have found with testing that this hovercraft goes very fast, at even with 8.4 volts, and there really is no need to use 12 volts. If you'd like, you certainly could use 12 volts and use a weaker fan, but for the fans we are using and the fans included in our materials list, using an 8.4 volt is more cost effective and will be more than enough to reach the minimum target time. So now what we are going to do is we are going to complete the wiring for the blower fan. First thing we are going to do is we're just going to confirm which end of this switch fits onto the battery. Now eventually what I'm going to do is I'm going to cut off both ends of the switch and attach inline lever connectors to all 4 wires. Now technically you don't have to do this with the side I'm cutting off right now, but I find that it's very helpful to make sure that these wires are as short as possible so that there's a lower chance of these switches falling off the hovercraft and hitting the track during the run. So what I'm doing now is I'm just taking some wire strippers and cutting off a decent portion of the switch wires, and then I'm going to take my inline connectors and connect all 4 leads from the switch, and then we are going to reattach the female connector that fits onto the battery onto one end of the switch, and on the other end of the switch we are going to connect directly to the blower fan wires. After doing this wiring, you can quickly turn on your fan to make sure everything is working. So the next step is to complete the wiring for the thrust fan, which is a little bit more complicated, but we're going to start off in the same way. The first thing we need to do is just we need to locate which end of our switch fits onto the battery. And again, you don't have to do what I'm doing here. What we're going to first do is we are going to cut off that end of the switch and shorten the wire there. And again, you don't have to do that, but I find that it makes things a lot easier. Now, one difference here is that the other end of the switch, we are not going to be using inline connectors. We are just going to be using the standard 2-way connectors. The reason for that is because we need to connect directly up to the rheostat, and using an inline connector could potentially make the wires stick out beyond the front dowel of the hovercraft, and you could potentially get a construction violation as a result. So again, we are going to first be using the inline connectors to connect to the battery, and the other end we're using the regular 2-way connectors. So part 2 of this wiring involves connecting the positive end of the switch to the input of the rheostat and the negative end of the switch to the black wire. Now from there, we are going to be attaching the output end of the rheostat. So again, the input end is the one attached to the gold terminal of the rheostat, and the output end is the one attached to the central terminal or the silver terminal on the rheostat. So again, the output end of the terminal is going to connect to the 3-way inline lever, actually not inline, but 3-way lever connector. And from that lever connector, we are going to attach to an output wire. So again, we preserve that output wire from the first switch. So we're going to attach the positive end of that output wire to the 3-way connector. And then of course we're going to connect the positive end of the motor wire, the fan wire, to that 3-way connector. And similarly, we are going to attach the negative wire coming out of the switch to that 3-way connector. And then in that 3-way connector, we are also going to attach the negative end of that output port and the negative end of the fan wire. Now the reason we need this additional port here is that later on we will be making a way to quickly attach and reattach a voltage gauge. Now this is very helpful. It essentially acts as a voltmeter that you can quickly use during the setup time at a competition. Now just a quick discussion of how this, or why this little system is legal. There is only a restriction on integrated circuits, which is what a voltmeter would be, or a voltage gauge would be, only when the vehicle is running. So during setup time, you are allowed to use these voltage gauges to calibrate your device. So again, making this port would just help quickly adjust your voltages and make things a lot easier for you. So the next step here is to assemble the voltage gauge that I was talking about in the previous step. So just like what we've been doing, we are going to be stripping the ends of this voltage gauge, attaching it to an inline connector, and then attaching the other end of that connector to a female terminal that fits onto that port we inserted onto the three-way connector. Again, just to discuss the legality of this, it is entirely possible and allowed to use a voltage gauge so long as it is removed before you start the run. Again, it is allowed to use internal circuits so long as they are not a part of the hovercraft when it starts to run down the track. So you can attach this voltage gauge to the port, adjust the voltage, and then unplug the voltage gauge from the hovercraft, and that is allowed in the rules. So again, we're just using this to adjust the voltage, then we're going to detach it and run the hovercraft. So after doing all this wiring, you're probably going to be left with a big mess of different wires. And something you can do is you can take some masking tape and you can tape together the different pairs of lever connectors. And what I'm also going to do is I'm going to put some different colored tape on the two connectors that connect to each other. And the reason for that is when you're at the competition and you're in the heat of the moment, things can sometimes go wrong, and you may connect the wrong battery to the wrong spot and things can go wrong. So I find it very helpful to put a little bit of colored tape to make sure you're actually connecting things in the right place. Another thing you would want to do here is it is beneficial to actually also put that colored tape onto your different batteries so that you're always using the same battery for the thrust fan and the same battery for the lift fan. There is a possibility that if you're using different fans, you may get different results, and that can also hinder your performance at competitions. So now what we are going to do is we are going to be adding some holes to our skirt, and you can see there's actually a little bit of a hole here that was created in the building process, but that doesn't particularly matter. So what I'm doing here is I'm just using a needle. You can also use a thumbtack or anything just to make a lot of tiny holes into the skirt. And I'm going to go through from the very top to the very bottom of the skirt with the fan on so it's inflated and you can actually feel the air coming out. We're going to go from the very top to the very bottom of the skirt, putting as many holes as possible. The more holes you can put in, the better. It makes the hovercraft glide better, but it does decrease the strength. Now, decreasing the strength is not something you need to worry about if you're using the fans we recommend in our materials list. Those fans have a very, very strong static pressure, which is able to overcome a lot of the weight and the extra force that the hovercraft does have. The next step here is to attach a 20 centimeter long, 1/4 inch diameter wooden dowel to that center hole at the front of the hovercraft. So let's take a quick second to make sure everything is working. If we turn on the thrust fan, the lift fan, the hovercraft can freely levitate and moves around pretty easily. And if we turn on the thrust fan, the hovercraft should be able to move forward. In this next step, we are going to be attaching a weight rack where we can adjust the amount of weight on the hovercraft. Now the reason for this is like essentially a secondary mechanism of adjusting your hovercraft's time, where increasing the weight will increase the travel time of the hovercraft to the end of the track. Now the reason we're doing this is because sometimes it is difficult to reach those really high target times in the 20s or even in the late teens. So having a weight rack where you can, adjust the weight to slow it down a little bit more can help you. So this is a quick demo on how to use the voltage gauge. Again, when you're at your setup time, or even when you're doing practice runs at home, before every run you should be checking the voltage coming out of the rheostat. And you should be recording the target time, or the actual track time you got with that specific voltage. Now, as you can see here, as we change the position of the rheostat, we can either increase or decrease the voltage. Now, obviously, as you increase the voltage, you're going to go faster, and as you decrease the voltage, you're going to go slower. Alright, so we discussed how we are going to use voltages and different masses on the hovercraft to get to the different target times. But how do we go about actually figuring out what voltage and what amount of mass we need? Well, the best way to do that is to test a bunch of different voltages at a bunch of different masses. Now, as you can see here, we have a graph, and I plotted, different values. On the x-axis, you have the target time, and on the y-axis, you have the target voltage. So each individual line you see here would correspond to a different mass. So the orange line perhaps would correspond to no extra mass, the black line with 100 grams, and the green line with 200 grams, and the red line, let's say, with 400 extra grams of mass on the hovercraft. Now at this, let's focus on this orange line first, just to understand the simple concept here, right? So between, let's say that blue line is at about 15 seconds, right? So up until 15 seconds, this graph is a very strong predictor of target time. And what I mean by that is that it takes a decent amount of change in voltage to get from 1 second, or get from, let's say, 10 seconds to 11 seconds, than it does to get from 15 seconds to 16 seconds. You can see that the slope is much steeper as you get closer to the y-axis, and it gets much shallower as you get further away. So essentially what we're doing here is we're testing different masses to see which set of masses would be able to give you the greatest ability to actually achieve that voltage, right? And so again, what I mean by that is, if let's say you're shooting for 20 seconds and you're using this orange curve with no extra mass, let's say that target voltage, the voltage to reach that target time is 6.66, right? But now let's say you want to do 21 seconds. That target voltage is not going to change a whole lot. Maybe it's 6.67, and it's very hard to adjust your voltage by 0.01 of a volt. Now, if we look at that red line, now we're targeting again 20 seconds. That voltage is maybe maybe like 7 volts. But at
21 seconds, that voltage is 6.8. Now, 0.2 volts is a much more reasonable change to achieve, and actually a very much more easier to get to a error or a specificity of 0.2 volts than it is to get to a specificity of 0.01 volts. So again, just a quick summary here, you want to test a bunch of different voltages at a bunch of different masses and graph the correlation of those times to the target voltages for each specific mass. And by doing so, you can generate a lot of different regression curves, and you can find the regression curve that would be able for you to best reach your target time. Again, by reaching the target time, I'm essentially saying here that you have a lot of wiggle room to actually achieve your target time without widely overshooting or widely undershooting the intended target time. And with that, your hovercraft should be built, and you should be well on your way to calibrating your hovercraft and getting ready for competition. With that being said, thank you for watching. If you have any questions, feel free to leave them in the comments below or reach out on our website. Thank you for watching. Stay unfazed.